In this video, we're going to build a combinational logic circuit on the breadboard. This is going to be the same circuit that you saw in the previous video that we built in Multisim. So to begin, we're going to need an inverter, which is the 7404. So if you don't already have your kit, grab your kit and some wires and follow along with me. First, locate the 7404, which is your inverter, and place it on the breadboard. Remember that the semicircle should be facing your left side. That way you can easily follow the pin diagrams to know which pins you need to use. You're also going to need the 7408, so locate that chip from your kit and place it on the breadboard. Make sure you remember which one is which. I did my inverter first and then the AND gate second. Now remember, before we can really wire a circuit and expect anything to happen, each chip needs power and ground. Power goes to pin 14, ground goes to pin 7. So I'm going to set that up next. I'm going to take a wire and go from the 5-volt source on the board, remember it can be any one of these holes on the bottom, down to the vertical bus. Then I'm going to take 2 wires and connect pin 14 of each chip to the vertical bus. Make sure you're getting pin 14 and not any other pin. Pin 14 and pin 14. Next, I need to set up ground. So I'm going to take a wire, unscrew the cap, make sure that the wire has a good connection, and screw back on. Should be very secure. And ground will go right here into the negative vertical bus on the bottom. From there, I'm going to take 2 small wires and connect pin 7 of each chip to ground. So now we have power and ground set up. Now we can begin to build our circuit, and I'm going to follow the circuit that was already constructed in Multisim. So if you look at the circuit from Multisim, and that was in the previous video, feel free to go back and review that if you need to. Pins 1 and 2 of the AND gate were inputs A and B. And I'm going to use the switches as my inputs. So you can use any switch you want, you just have to remember which switch you picked and how you labeled it. For example, if I'm going to have switch 7 be input A, I'm just going to have to remember that. You might want to take yourself a little note on the side so you can remember which one was A, which one was B, and which one was C. Typically you want to go in order from left to right. So I'm going to select switch 7 as input A. And I'm going to connect input A to pin 1 of the AND gate. So there's input A. Input B is also going to be a switch. Remember, any input that you have is always going to come from one of the switches up top. So input B is going to go right here into pin 2 of the AND gate. Now according to our diagram, pin 1 of the inverter is the 3rd input. So I'm going to take a 3rd wire, and that will be input C. And, oh, my wire is not long enough. Pin 1 of the inverter is going to go to my 3rd switch. So I have input A going to pin 1 of the AND gate, input B going to pin 2 of the AND gate, and input C going to pin 1 of the inverter. This is exactly how the circuit was designed in Multisim. Now, going forward, pin 3 of the AND gate should be connected to pin 4 of the AND gate. The output of one AND gate becomes the input to the next in our diagram. So that's how we're going to wire it. The output of pin 3 becomes the input to pin 4. So I'm going to need a small wire to go from pin 3 to pin 4. Just like that. Next, I can see that the output of the inverter, which is pin 2, has to go to pin 5 of the AND gate. So I'm going to take a wire and go from pin 2 to pin 5 of the AND gate. There's pin 5 right there. And lastly, pin 6 is the output. That's the final output, and that is the pin that's going to go to an LED. So take a wire and go from pin 6 up to any LED of your choice. And now it's ready to test it. In order to test this, we are going to have to follow the truth table that we've already created in Multisim. Remember, the truth table is your roadmap. It tells you how the circuit is supposed to work. So we're going to turn on the circuit now, and we are going to manipulate the switches to match the inputs of the truth table and make sure that the output is correct. So according to the truth table, when all of the inputs are low, that would be 0, 0, 0, the output is low. The next row has input A as low, input B is low, and input C is high. That would be 0, 0, 1. No light. The next input is 0, 1, 0. No light. The next row is 0, 1, 1. Still no light, but that's okay. We weren't expecting a light because based on the truth table, these outputs should all be 0. Let's keep going. The next row of the truth table has 1, 0, 0. So that's my inputs. 1, 0, 0. Still no light. The next input is 1, 0, 1. Still no light. That's good. The next input is 1, 1, 0. And there's the light we expect. Because according to the truth table, the only time the light should come on is when input A is 1, input B is 1, and input C is low. And then the last input is when they're all high and the light goes off. So we have verified that our circuit works as expected. The only way to verify it is to test all 8 possible inputs. You can't just test 1 or 2, you have to test all 8. And we did that from top to bottom of the truth table. So our circuit is working. If your circuit is not working, some things you may want to check is that your ground is connected properly, that power is connected properly, that power is connected to pin 14 on each chip, and that ground is connected to pin 7 on each chip. Also make sure that you have wired it exactly the way that I wired it, using all of the pin numbers shown in the Multisim circuit. If it's still not working at this point, raise your hand and get a lab assistant to help you.